Imagine a dragonfly with a wingspan wider than a hawk, hunting through primordial forests where the oxygen itself is poison to modern lungs. This isn't science fiction. This is Earth, 300 million years ago, and the insects ruled with an iron grip. We think of dinosaurs as the ultimate prehistoric monsters. We picture T-Rex, we imagine the long-necked giants. But there was an entire epoch stretching across tens of millions of years where insects weren't just pests to be swatted away. They were apex predators. They were titans. And the battles they waged make modern nature documentaries look gentle. This is the story of the Carboniferous period, a time when the planet became an alien nightmare, and insects evolved into forms so monstrous, so bizarre, that they challenge everything we think we know about the limits of biology. Let's go back. 360 million years ago, the world is unrecognizable. Continents are fused into supermasses. There are no flowers, no grass, no birds singing in the trees. The forests are made of massive club mosses and towering ferns, some reaching heights of 40 meters. The ground is a swamp, thick with rotting vegetation that will one day become the coal deposits that power our modern world. Hence the name, Carboniferous, the coal-bearing period. But here's what makes this time truly alien. The atmosphere contains 35% oxygen. Today, we breathe air that's 21% oxygen. That might not sound like a huge difference, but in biological terms, it's the difference between a house cat and a lion. Oxygen is fuel. More oxygen means more energy. More energy means bigger bodies. And insects, with their primitive breathing systems, hit the evolutionary jackpot. Unlike mammals, insects don't have lungs. They breathe through a network of tubes called tracheae that deliver oxygen directly to their tissues through passive diffusion. It's an elegant system, but it has a fatal flaw. It doesn't scale. In modern atmospheres, an insect can only grow so large before its body becomes too big for oxygen to diffuse to its core. The insect suffocates under its own mass. But pump up the oxygen levels and suddenly, that limitation disappears. The diffusion gradient becomes steeper. Oxygen floods deeper into tissues, and insects start growing, and growing, and growing. Enter meganeura. The word itself sounds like a prophecy of doom. Meganeura moni, to be precise. A dragonfly that would make your skin crawl if you saw it hovering outside your window. Its wingspan stretched 75 centimeters. That's nearly 2.5 feet, wider than a red-tailed hawk. Imagine that hanging in the air, its compound eyes tracking movement with the precision of a guided missile. But meganeura wasn't just big, it was built for slaughter. Those eyes contained up to 30,000 individual lenses, giving it a panoramic view of the world with almost no blind spots. Its reaction time was measured in milliseconds. Modern dragonflies can intercept prey in midair with a success rate of 95%, making them the most efficient hunters in the animal kingdom. Meganeura would have been even deadlier. Faster reflexes, stronger muscles, a killing machine refined by millions of years of aerial combat, and it wasn't hunting mosquitoes. The Carboniferous swamps were filled with other giants. Arthropods, a millipede as long as a car, wound its way through the undergrowth. It could grow up to 2.5 meters in length. Picture a millipede the size of an alligator, armored in chitinous plates, potentially venomous, definitely terrifying. These creatures grazed on the rotting plant matter, but their size made them formidable even as herbivores. Then there were the eurypterids, sea scorpions. Some species reached lengths of over 2 meters. They prowled the shallow waters in coastal regions, ambushed predators with crushing claws and stabbing tails. Though their heyday was earlier, In the Silurian and Devonian periods, some lineages persisted into the Carboniferous, continuing their reign of underwater terror. But let's return to the air, because the aerial battles of the Carboniferous were unlike anything before or since. Meganeura wasn't alone in the skies. There were dozens of giant insect species competing for dominance. Other griffinflies, as paleontologists call this group, filled every niche. Some were ambush predators lurking in the canopy. Others were pursuit hunters, capable of sustained high-speed flight. The forests echoed with the hum of chitinous wings, a sound that would have been deafening. Here's where it gets fascinating. These insects didn't just grow large, they evolved completely new hunting strategies. Modern dragonflies hunt individually, relying on speed and precision. But evidence suggests some Carboniferous species may have exhibited swarming behavior. Imagine hundreds of these giant predators moving in coordinated patterns, creating aerial kill zones from which smaller flying insects couldn't escape. The sky itself became a trap. And what were they hunting? Other insects, primarily. The Carboniferous saw an explosion of insect diversity. Primitive cockroaches, some as large as your hand, scuttled through the leaf litter. Early relatives of mayflies and grasshoppers took their first tentative flights. Many of these species were larger than any modern counterparts. A cockroach 10 centimeters long, a mayfly with a 15-centimeter wingspan. In the Carboniferous, everything was scaled up. But here's the catch: the arms race went both ways. If predators grew larger, so did prey. And prey evolved defenses. Some developed thicker armor. Others evolved camouflage patterns that blended with the mottled bark of giant club mosses. Still others evolved toxic compounds, chemical warfare that made them unpalatable or outright poisonous. The evolutionary pressure was immense, relentless. And then there were the spiders. Yes, spiders aren't insects, they're arachnids. But in the Carboniferous, they were just as monstrous. Some species grew large enough to hunt small vertebrates. Early amphibians, no bigger than your finger, were fair game. The spiders spun webs between the massive ferns, sticky death traps that could ensnare insects the size of modern birds. This leads us to a critical question. Why did these monsters disappear? The answer is written in the rocks, in the chemistry of ancient atmospheres preserved in amber and sediment. Around 300 million years ago, oxygen levels began to drop. Slowly at first, then more rapidly. The coal swamps were drying out, replaced by more arid environments. The massive club moss forests collapsed, and with them, the oxygen factory that had sustained the giants. As oxygen levels fell, insects began to suffocate. The largest species were hit first. Their massive bodies required enormous amounts of oxygen, and the passive diffusion system that had served them so well became a death sentence. They couldn't evolve fast enough. Within a few million years, most of the giants were gone, but some survived, they shrank, they adapted, and their descendants are still with us today. Modern dragonflies are marvels of engineering. They can fly backward, hover in place, reach speeds of 50 kilometers per hour. But they're shadows of their Carboniferous ancestors. A modern dragonfly has a maximum wingspan of about 15 centimeters. Meganeura was 5 times larger. The size difference is staggering. Yet, even in their diminished state, dragonflies remain apex predators of the insect world. That 95% hunting success rate isn't a fluke. It's the legacy of 300 million years of evolutionary refinement. Every modern dragonfly carries the genetic memory of an age when insects ruled the earth. Here's what haunts me about the Carboniferous. We live in a world where insects are small, manageable, easily ignored. We swat flies without thinking. We step on ants. But for tens of millions of years, Insects were the dominant predators on land and in the air. They weren't competing with mammals or birds. They were the top of the food chain. And if oxygen levels were to rise again, if the atmosphere were to shift back toward those ancient ratios, there's nothing stopping them from reclaiming that throne. Scientists have run the experiments. In laboratory conditions with elevated oxygen, modern insects grow larger. Not meganeura-sized, not yet, but the potential is there, locked in their DNA. The blueprint for gigantism never disappeared. It's just dormant, waiting. This is the true terror of deep time. We think of evolution as a ladder, with humanity at the top. But evolution is a wheel. It turns. Species rise and fall. Ecological niches open and close. The Carboniferous proves that the planet doesn't belong to any one group of animals. It belongs to whoever can adapt to the atmospheric conditions, the climate, the ever-shifting chemistry of air and water. The wars of the Carboniferous insects weren't just epic because of their scale. They were epic because they represent a fundamental truth about life on Earth. Survival isn't about being the strongest or the smartest. It's about being the most adaptable. The insects of the Carboniferous thrived not because they were destined to rule, but because they happened to be in the right place, with the right physiology, at the right time. And when that time ended, they adapted again, they shrank, they diversified. Today, insects make up 80% of all known animal species. They've conquered every habitat on Earth except the deep oceans. They've outlasted the dinosaurs. They've survived multiple mass extinctions. In many ways, the insects already won. They just don't look like monsters anymore, but walk into a forest at dusk. Watch a dragonfly intercept a gnat in mid-flight. Its movements too fast for your eyes to track. Listen to the cicadas, their chorus a reminder that insects still own the summer nights. And remember, 300 million years ago, their ancestors cast shadows across the swamps. They ruled an alien Earth. And in their own way, they still do. The Carboniferous period wasn't just a chapter in the history of life. It was a warning. The conditions that create monsters aren't gone. They're just sleeping. And evolution never stops turning the wheel.